So in this video, we will discuss about a very interesting topic. Whenever there is any kind of shock or jerk, we are using a very beautiful mechanical element. That element name is spring. For our comfortable life also, you are using the spring. Starting from our sleeping mattress to sitting sofa, everywhere the spring is used for our comfortability. That comfortability, that is not so crucial, that is not so important, but there are some important area where the use of spring is mandatory, automobile industries, that is opening and closing of inlet and outlet valve. Spring is must required there. And shock absorber of any automobiles also, they are using the spring for observe the shock from the roughness of the road. And if we'll talk about any toys, watch, and like this, several mechanical equipments are there where clutch, brakes, everywhere the use of spring is mandatory. That much powerful it is, right? So it is a beautiful, that means most important mechanical elements. Without these mechanical elements, most of these systems, most of the machineries will be fail. Their life will be reduces. And for human compatibility life also, you are using this instruments, that mechanical element named as spring. Today we are going to discuss about the spring. So I am Subhrajit Sahu, assistant professor in Narasimha Reddy Engineering College. I would like to welcome to my channel. So in this video, I will discuss about in details what is a spring, what are the several classification of spring, and what are the several factors that are affecting the performance of the spring. In details, we will discuss in this video, right? Now, first, what is a spring, sir? Spring is, you can say, by using spring, is there a chance to store the energy? Yes. Spring is used to store energy. Whenever the spring is compressed, compressed or tension, whenever the spring is subjected to compression or tension, the energy is stored in the spring. Energy is the stored in the spring. That energy is stored potential energy. Potential energy. The spring is stored potential energy whenever it is compressed or it is subjected to tensions. And or we can say the definition of this spring, it is elastic body. Elastic body which function is to distort when loaded and recover its original position so when load removed. When it is loaded, it will be change its shape, and when the load will be removed, it can come back to its original positions. So by doing this, we can avoid shock, vibrations, minimize the vibrations. Like these several things, I told the several examples where the applications where the spring is used. We are fully surrounded with all the mechanical equipment surrounding to us, and each and every mechanical equipment, there is the use of spring. That much powerful it is, the spring. Without spring, every systems will be fails. Every system will be fails. That means the importance of the spring in the field of mechanical engineering is essential and very, 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 very important. We cannot neglect this one. And in this chapter, in this subject, I'm going to discuss about in details from the crash level to advanced level. Crash level to advanced level, I will tell. Sir, I told about the introduction about the spring. Sir, what are the several types of springs? There are several types of spring based on load applied. Based on load applied, it may be classified into three types, right? What are the three types? Sir? First one is, observe, torsion spring. Torsion spring. Already this torsion spring, you see this kind of picture we are using to fix the washing cloths, right? The clips. Here, this kind of spring is called as torsion spring. That means when the load will be applied, here a punch figure is there. Okay, double punch for make a hole in the paper. Here the spring is used. This kind of spring is used here. Whenever we apply the load here, the spring will be turn, it will be twist. That's why it is called torsion spring, right? Similarly, this one, another type based on the load applications, tension spring, right? Tension spring, it is a closely coiled spring, closed coiled spring, tension spring. Where is the application, sir? Generally in the bicycle stands we are using. To stand the bicycles, we are using this spring in this stand. And another types of spring is there based on the load applications, that is compression spring. Most of the cases we are using this type of spring, compression springs. Rare this tension and this torsion spring are used. Most of the toys we are using the torsion springs. Okay, na? But this compression spring applications widely it is used in starting from this mechanical industry to toys also. Everywhere 80 to 90% we are using the compression type spring load based on the loads, right? Sir, the selection of material to manufacture to produce a spring is very very important. Sir, what kind of material is suitable for the manufacturing of springs? Here the list of material is there. Stainless steel we can use, carbon value, oil tempered steel like this, chrome silicon, titanium, monel, all these things we can use for the spring materials, because these materials are very much suitable uh, in properties for the manufacturing of this spring, right? So this is the little classifications of the spring. Also the spring can be classified based on shape, right? based on Based on shape also it can be classified the following types. What are those, sir? Based on shape, the first three one I told based on load applied. Now based on shaped, it is helical spring. First one is helical spring. Okay, na? Helical spring. Again, this helical spring can be classified into closely coiled, closely coiled, or open coiled helical spring. Okay, open coiled helical, closely coiled, closed coiled, or open coiled helical spring. Then it can be classified into based on the shape. Okay, based on the shape, 1 minute. This is one. Based on the shape, it can be classified into conical shape. Okay, conical shape, or it is also called as volute spring. Volute volute spring, conical or volute spring, right? Then torsion spring also I told based on the load applications. Third one is lip spring. Lip spring, in the uh, heavyweight vehicle, truck, buses, we are using the lip spring, plate type of material, plate type of shapes. So these are the several uh, types of spring. Based on the shape of the spring we are classified. So we can classify it based on different several categories also. So these are the importance in the um, very very important. Frequently we are using this kind of springs, right? So next is what? Next is, observe here. So here in this picture, what I'm trying to show you in this picture, 1 minute, control C, take here. In this picture I will show you this angle. What is the angle, sir? This angle is called helix angle, right? The angle is called helix angle. What is the angles? To the horizontal axis, to the axis of coil. Okay, na? Axis of coil. This is a horizontal axis. Okay, 1 minute. This is the horizontal axis, and axis of this where axis of this where it is create one angle, right? This angle is called helix angle, and this helix angle will be decides your spring is closely coiled, closely coiled, or open coiled, right? Open coiled. So how to know it is a closed coiled spring or open coiled spring? Based on this helix angle. If the alpha is less than 10 degree, then it is a closed coiled spring. If the alpha is greater than 10 degree, then it is a open coil spring. Now this is a open coil spring because this angle will come more than 10 degree, and when the alpha is less than 10 degree, that means less than 10 degree, 7 6 7 equivalent to 0 degree, 0 to 10 degree, then it is called a closed coil spring. In the next slides I will discuss about this closely coil and open coil spring in details, right? Next one is observe. Most important parameters here, we need to understand this one. Okay na? Observe here, sir. Sir, in this diagram, you see, this is the cross section of the spring. We can say it is a coil. Sir, how many parameters are there? So this is called inner diameter. It is denoted by the symbol di, capital Di, and this is outer diameter. It is denoted by the symbol do. Apart from this two diameter, one more diameter will come, mean diameters, right? Mean diameter means exactly at the middle, like this. Mean diameter will come like this. Mean diameter will come, and it is denoted by the symbol as per your data handbook or any textbook. It is denoted by the symbol D. Sir, why I am talking about, why I am telling this one? Because in the problem sometimes D value directly given, or sometimes a di will be given, sometimes a do will be given, but anyhow you have to find the d only. If it is directly given, so far so good, no problem to find out. But if do is given, then you have to find the d. Then how to find d? If do is given, then d can be find out equal to do minus d. Okay, see, this is do. Okay, so here to this red color to this red color, it is a D, right? It is D. Here to here, it is D. Then I will minus this radius. This is the wear diameter. Wear diameter is small d. This wear diameter is small d. So I have to minus this radius, and I have to minus this radius from the du. Then I will find the d. So this radius, 2 times radius is nothing but d. So du minus d is give d. Similarly, if the di is given, then what I will do? I have to find d. D become di plus d. I have to add the 2 times radius. Then I will find the diameter, mean diameter of the coil. Because in the next slide we will discuss the several formulas which are using to calculate the stresses developed, deflections, all these things, where the formulas are derived on the basis of mean diameter, not outer diameter, not inner diameter, right? So that's why the D is important to find out. It is very easy. You can easily find out, right? Just I tell the way. Now, sir, what is the next important point here? Sir, this is a compression spring. This is a compression spring. That means this spring will be loaded like this. Load will be acted like this, right? Okay. Now, before load, what is the length? It is visible. This length is called free length. The length is called free length. And when it will be loaded, the spring will be squeezed, compressed. I will show you the diagram also, don't worry. Here, see. Now this is the free length, and load is applied to this free length. 1 minute. Here. To this free length, the load is applied. This load is applied, and this spring is squeezed to this much length. Okay. So that means here some pitch will be there. Pitch is what? Coil to coil distance is called pitch. Okay. So here this coil to this coil distance is called pitch of the spring. So here some pitch will be visible, but when the load will be applied on the spring, the coil will get closer, and approximately the pitch become 0, coil to coil touch. But generally it is not allowed that you apply that much load so that coil to coil touch will be happen. If coil to coil touch will be happen, then this spring will be act as a shaft only. It will act as a shaft only. Then there is no useful, no benefit of using of spring. That means some load capacity for different types of spring is there. You cannot load beyond the limit. If you are giving the load beyond the limit, then the spring functionality is not that means the functionality of the spring will be fails. For we are using the spring for observation of shock and vibrations. If the spring contact will be there, it will becomes in contact, pitch becomes 0. It will not observe the shock, it will not observe the vibrations, right? So load should be applied based on the restriction, based on the limitations, right? So this is the solid length. When the coil to coil contact will be done, this is the solid length, and this distance is called maximum deflection. It is denoted by symbol del max. Okay, del max. Okay. So what the company, how the company is manufacturing the spring? Based on these parameters: delta max, solid length, and the company is giving also clearance. Okay, because they know whenever the user is purchasing the spring, they will overload. So for that they are giving the clearance also for the safe side of the spring. Okay, so whenever the spring is manufactured, the free length of the spring, the company manufacturing, by considering these three parameters: delta max, what is the solid length, and what should be the clearance. And this clearance value, they are keeping 15% of delta max. 15% of delta max. See, so from this we can write LF equal to, what is the solid length, sir? LS, suppose solid length, and maximum deflection. Maximum deflection means when pitch becomes 0, delta max. Okay, plus 15% of clearance means 0.15 of delta max. 15% clearance they are giving. If I will simplify this one, I will get LF equal to LS plus 1.15 delta max. This is the pre-length. When the company will be manufactured, the company has to manufacture this much pre-length based on this load. How much load applied here? P load suppose applied. For this P load, he has to manufacture a spring whose pre-length should be LS plus 1.15 delta max, right? Here, 1 minute. Here, this is the derivations, right? How it is derived, I just explained. Okay. What is the next, sir? Next is it is called buckling, right? Okay, 1 minute. Buckling of the spring. What do you mean by buckling of the spring, sir? No, buckling means this bending. Okay, 1 minute. I will take to this one to here. Sir, here to here length is called, here to here length is called free length, LF, right? LF, it is called LF. Sir, whenever the company is manufacturing the spring, he should take care what should be my free length. If the company is keeping very large free length, then problem. If the company is keeping very short free length, then problem. Because if very short free length will be there, very less free length will be there, then with the application of load, the pitch becomes 0 and coil to coil contact will be done. Then coil to coil contact means there is no use of spring. There is no advantages to use of spring, because it will be act as a shaft only. It will cannot bear any shock, cannot bear any vibrations, right? So the spring free length should not be less, and the spring free length should not be more also. If it is more, then what is the problem? Let us try to understand, if the spring free length become more, then what will be the problem will be happen. Let us try to understand this one. Very interesting. Suppose this is a bar, right? This is a bar, shaft. Now it is a column or bar. Length is very short, right? This length is very short, and this bottom edge it fixed. The bottom edge it is fixed, right? Now suppose the diameter is D, capital D, and length is L. Now what I will do, sir? I will don't change this diameter D. I will don't change this diameter D, but I will make the length a very big length. Diameter I will not change, but length I will make it big. Then what will be happen? You know, automatically the bending formation will be done. Automatically the bending formation will be done here like this. Because the shaft is not getting the base support because the diameter is less and the length is much more large. That's why automatically this bar or this pole is get bent. You might have seen in the building constructions they're using the rod. If the rod length is more, the rod automatically bend, right? Because its diameter is less but the length is more. That means the shaft, if I want the shaft should be straight, then I should take care this length and diameter ratio. Okay na? For a particular diameter I should take a particular length. I cannot take a big length for a particular diameter, because if I take a big length then it will be bent. Then what is the solution, sir? Solution is, what is the solution? If you are taking length more, 1 minute guys, 1 minute.